In this video, we'll be talking about linear equations. Linear equations are equations whose graphs are lines. By the end of the video, we'll be able to identify when a certain equation is a linear equation. We'll also want to be able to tell when an equation has the graph of a horizontal or vertical line. First off, a linear equation is an equation of the form ax plus by equals c. In these equations, the a, b, and c are constant real numbers, whereas the x's and y's here are your variables. One key feature is that your x and your y are just to the first power. You'll never see any squares or cubes, any square roots. You don't see a product of x times y. You just have some constant times x to the first power plus some constant times y to the first power. Again, these are called linear equations because the graphs of these equations are lines. Let's take a look at some equations and decide whether or not they are linear equations. In example A, we have 2x plus 3y equals 4. This looks exactly like the form ax plus by equals c, with a being 2, b being 3, and c being 4. So our first example here is an example of a linear equation. In example B, we have x squared minus y equals 5. This is not a linear equation because of this square here. Remember that for a linear equation, the powers for the x's and the y's are at most 1. So whenever we see a power on an x or a y that's not 1, like this x squared here, we have a non-linear equation. In example C, we have y equals 3x plus 1. While this equation doesn't quite look like ax plus by equals c, the powers for the x's and y's are both 1, which suggests to me that it is a linear equation. And if we do want to rewrite our equation so that it looks like ax plus by equals c, all we have to do here is subtract 3x from both sides. If we subtract 3x from both sides, we end up with negative 3x plus y equals 1. And now it looks more like ax plus by equals c, with a being negative 3, b being 1, and c being 1. So it turns out that this is a linear equation. In example D, we have 6x plus the square root of y equals negative 7. Here we can rewrite this equation as 6x plus y to the 1/2 power equals negative 7. Remember that any radical can be rewritten as a fractional exponent. So all we're doing here is we're rewriting the square root here as a 1/2 power. Remember that for a linear equation, we can only have x to the first power and y to the first power. And in this equation, we have y to the 1/2 power. So the equation we have here is not a linear equation. In our last example, we have y equals 3. And once again, it doesn't quite look like ax plus by equals c, but we can rewrite it in that way. Since there's no x's in this equation, we can think about this as having 0 copies of x plus 1 copy of y equals 3. Rewriting it in this way, we see that it now looks like ax plus by equals c, with a being 0, b being 1, and c being 3. So this is a linear equation. This last example actually gets us into our next topic, which is about horizontal and vertical lines. Horizontal lines have equations of the form y equals c. The last example from the previous page, y equals 3, is an example of a horizontal line. Let's try to graph it ourselves to see why such an equation would give us a horizontal line. From a previous video, we learned that to check whether a certain point is on the graph of an equation, we can plug in the x and the y coordinates to see if we end up with a true statement. So for example, if we wanted to check whether the point 3, negative 2 is a point on the graph of the equation y equals 3, well, we would take the x coordinate 3 and the y coordinate negative 2, we would plug it into the equation and see if we end up with a true statement. Now, there's nowhere for me to plug in x equals 3 into the equation but we can plug in y equals -2 in, and we see that we end up with -2 equals 3, which is not a true statement, so we know that 3 comma -2 is not a point on the graph. On the other hand, we can try plugging in the point like 0 comma 3 into our equation. We would plug in x equals 0 and y equals 3. Again, there's no place for me to plug in x equals 0 because my equation doesn't have any x's in it. However, we can plug in y equals 3 and we end up with the equation 3 equals 3, which is a true statement. So we know that 0 comma 3 is a point on my graph. Let's try to come up with some other points that would be on the graph of this equation. For example, 2 comma 3 would also be a point on this graph because if we try to plug in x equals 2 and y equals 3, we end up with 3 equals 3. It doesn't really matter what the x-coordinate is because there are no x's in the equation. So no matter what the x-coordinate is, as long as the y-coordinate is 3, we would end up with 3 equals 3, which is a true statement. So we can have other points like 5 comma 3 here, or a point over here like -1 comma 3, or -4 comma 3. All of these would be points that are on the graph of this equation. Now if we collect all of these points and see what pattern we end up with, it looks like we have a horizontal line. So we can connect all of these points to get our graph. So in general, whenever you have the equation y equals c, you're going to end up with a horizontal line at the y value c. We end up with vertical lines when we look at equations of the form x equals c. As an example, we can look at the equation x equals 2. Again, let's draw the graph for this equation to confirm for ourselves that this is a vertical line. This time, a point like -1 comma 4 would not be a point on the graph of this equation because we would plug in x equals -1 and y equals 4 into our equation. Plugging in x equals -1, we end up with -1 equals 2, which is not a true statement, so this point is not on our graph. On the other hand, a point like 2 comma 0 would be on the graph of this equation because we would plug in x equals 2 and y equals 0. In our equation here, there's no place for me to plug in y equals 0, but we would plug in x equals 2. So plugging that in, we get 2 equals 2, which is a true statement, so this is a point on our graph. Since the equation does not contain any y's, it doesn't really matter what the y-coordinate of the point is. As long as the x-coordinate is equal to 2, the point is going to be on the graph of this equation. So we can have points like 2 comma 1 or 2 comma 4, or down here like 2 comma -3. Connecting all of these points together, we see that the graph of our equation is a vertical line. So in general, if you have the equation x equals c, you're going to have a vertical line at the x value c. So in this video, we've learned how to identify when an equation is a linear equation, and we also learned that horizontal lines have the form y equals some number, and vertical lines have equations of the form x equals some number. In our next video, we'll learn about the slope of a line, which is one of the key features of a line.